Let's now check a second example. Now in this case, and it is very so much tested, we're supposed to find the unknown terms that makes a function to be analytic. So given that fz is given by that function, you're supposed to determine the value of a and the value of b such that this function becomes what? F of z becomes analytic. Okay, so solution. So the process is the same. We know for analytic function it has to satisfy these two conditions. These should be the same as dv dy, and dv dx should be the same as negative of du dy. So we identify our u and our v. So our u function is the one without the j, so it is that function. All right, then our v part will be bxy minus 2y. All right, then differentiate this function with respect to x and with respect to y. Again the same with respect to x and y. So we have du dx and du dy, sorry. So remember, we are only differentiating function with only the variable x. So we have x here, so we shall have 2x. We also have a x minus 2. Differentiate with respect to y, so this function has a variable, so we have negative 2. Sorry, not negative 2, negative a. Yes, negative 2a, sorry. Yes, negative 2a, 2ay. There's no other variable with a y. There's no other term with the variable y. Then we come again here, dv dx and dv dy, so equals to. Now with respect to x, we have this variable, so we have we shall remain with by. Then with respect to y, we have this and this, so we shall have bx minus 2. All right, so we have bx minus 2. So now for our function to be analytic, this condition and this condition have to be met. Okay, so now we compare our du dx with our dv dy. So our du dx is 2x minus 2, and our dv dy is bx minus 2. So if you just compare directly the two functions, you can see we have a negative 2, we have a negative 2, we have an x, we have an x. So therefore, if these two functions are the same, therefore the value of b becomes what? The value of b becomes 2. All right, I hope you can already see that. So our value of b is 2. Now we come to the second property. The second property says that your dv dx should be the same as negative of du dy. So dv dx is given by by, should be the same as negative, right? So that negative is important. So negative of du dy. Our du dy is b. Our du dy is this function here. So negative 2a, negative 2ay. Right, together. So again, by equals to negative gives you a positive, so it is 2ay. So we have, but remember, we know what our value of b was. Our value of b is 2y equals to 2ay. So excluding the y, we can now compare this variable, this term here, the constant and the constant. So therefore we say 2a, 2 on the left hand side should be the same as 2a. Okay, so therefore divide by 2, your value of a becomes what? Your value of a becomes 1. So therefore, for this function to be analytic, then therefore your value of a is 1 and your value of b is 2. So you can just rewrite the function, and you can always prove it that indeed if replacing the values that you have there, then that function becomes analytic. So now we have our third example here, that given that w equals to that function, determine the value of a and b such that fz is constant. Remember, these are questions that are tested from the NEC paper, so you can I think this was July 2020 series. So now the solution. So again, the first step is always first of all, you can just write our formulas here. Should be the same as dv dy, and our dv dx should be the same as negative of du dy. Then identify your u, your u is given by ax cubed minus 3xy squared. Okay, it is the function without the j. All right, together. Then you have your v is given by bx squared y minus y cubed. All right. Then differentiate with respect to x and with respect to y. So remember, this is partial derivatives. Okay. Yes, it is partial derivative where you only differentiate the function with respect to the variable you are differentiating with respect to. So if you are differentiating with respect to y, only the part that has a x, that is where you just put that is just where you differentiate. Differentiating with respect to y, you differentiate only the function that has the y variable. So in our case here, this and this both have what? X. Okay, so when you differentiate these, you get 3ax squared. The rule of differentiation: drop the power, reduce the power by 1. Then you have here the x is only 1, so therefore we always say the x goes, we just say it becomes 2 power 0, and anything 2 power 0 gives you what? Gives you 1. Okay, yeah, so this one goes. Okay, then with respect to y, there's no y here, so we differentiate this, so you drop the 2, it gives you negative. Remember, a value carries a sign before it, so there's a negative here. Right, together. So this one becomes 6x, then reduce the power by 1, so negative 6xy. Then you come to dx, sorry, and you have dv dy. So you have that. Again, with respect to x, there's a variable x here, so we'll have 2bx, 2bxy. All right, there is no x here. Then you come to y. Y is 2 power 1, so it becomes 2 power 0. Therefore, we have bx squared only, then minus 3y squared. All right, so 3y squared. So we have that. Now we compare. We now check our two equations, the Cauchy-Reimann's. So we check the two. So our du dx, what is our du dx? 3ax squared minus 3y squared. What is our dv dy? It's here, bx squared minus 3y squared. Now just compare the two functions. So we have 3y squared here, negative 3y squared here. Then we have bx squared, then we have 3a squared. So 3ax squared. So that means if you take 3a, whatever is at 3a should be the same as b. Are we together? Because everything else is the same. So 3a should be the same as b. Now you cannot get an answer here because we have two unknowns and we only have one equation. Now let's go to the second. The second says that when you have where is it here, dv dx, which is this function here, so 2bxy should be the same as negative of du dy, so negative 6xy. Right, together. So therefore 2bxy should be the same as 6xy. So working with the variables xy, xy, therefore your 2b should be 6. So therefore from that we know our 2b should be 6. Therefore divide by 2, your b value should be 3. Now you come to the second part where we had 3a equals to b. So our b value is 3, so 3a equals to 3. So therefore divide by 3 both sides by 3. So by 3, 1. So a equals to 1. So therefore your value of a equals to 1 and b equals to 3 for that particular function to be analytic. So functions tested in terms of analytic functions, that is just the two properties have to be met for any function for it to be analytic. So it can be analytic or not. So you always have to just confirm if it is or not. So thank you and see you in the next lesson where we shall be going to be checking on harmonic functions.